In this video we're looking at 2021 paper 2 question 7. It's all about distance, speed and time and trigonometry. Mary is taking part in a triathlon and she starts off at C and swims 4 kilometers to B. Then she travels from B to A cycling and then she runs 28 kilometers and that's the end of the triathlon. What we're asked to do in the first part of this question is to determine the entire distance. What is 28 plus 4 plus this distance? Essentially, it's find the distance from B to A. And the information we know about the cycle is that her speed is 25 kilometers per hour and the time it takes her to do the cycle is 1 hour and 12 minutes. So we're going to use that to find the total distance. We're going to add 28 and 4 and the distance BA and it'll add up to 62. Now, you just have to be a bit cautious here. The speed is in kilometers per hour and the time is in hours and minutes. We need to convert the minutes into point something of an hour. And obviously there are 60 minutes in an hour. So in order to convert minutes into hours, you divide by 60. 12 divided by 60 is 0.2. That tells me that 1 hour and 12 minutes is the same as 1.2 hours. Or in other words, 12 minutes is 1/5 of an hour. So I'm going to use T as 1.2. Think back to that triangle we used in question 5. To work out your distance, it's simply speed multiplied by time. So the distance that she has to cycle is 25 multiplied by 1.2. And if we plug that into our calculator, 25 by 1.2, the distance she travels on the bike is 30 kilometers. So that simply tells me the distance from B to A is 30 kilometers. And the question was to add them all up and prove they add up to 62. In this case, 30 plus 28 plus 4, the total distance traveled in the triathlon is clearly 62 kilometers. In part B, we're told that Mary runs 5.6 times as fast as she can swim. And it takes her 4.8 hours to do the entire triathlon. We're asked to work out what speed can Mary swim. So I've just written out all the information here. Obviously, ultimately, we're concerned here with the length of time. We know the total time is 4.8 hours. What we know about the swimming is that the distance is 4 kilometers. And I decided to label the speed she swims at as X. And I don't know what the time is for the moment. And then the information we know about the running is that the distance is 28 kilometers. And since I referred to as her swimming speed as X, the running speed is 5.6x. Or in other words, 5.6 times faster than she swims. Now, I know that the time for the swimming plus the time for the cycling plus the time for the running adds up to 4.8. If I want to work out time, it's simply distance divided by speed. So the length of time she's going to take on the swim is going to be 4, the distance, divided by x, the speed. If I take the time it takes her to swim, plus the time it takes her to cycle, which we used in part A, it's just 1.2, plus the time it takes her to run, and remember to work out the time, it's distance, which is 28, divided by speed, which is 5.6x. If I add them all up, I know that they have to add up to 4.8. So just look at what we have here. We've got one equation and one unknown, so we can simply solve this. This is the time for the swim, the cycle, the run. Add them up, I get the total time. Now, the first thing we might do is subtract 1.2 from both sides, just to get rid of that extra term on the left. If we subtract 1.2 from both sides, 4.8 minus 1.2 is 3.6. So we're left with an equation now, and the main concern here is the presence of the fraction. So I decided to multiply everything by 5.6x. That gets rid of all of our fractions. On the first term, essentially the x and the x cancel, and it's just 4 by 5.6, which is 22.4. If I multiply the second term by its denominator, I'm just left with 28. And 3.6 by 5.6x is 20.16x. We just add up the terms on the left, divide both sides by 20.16, we end up with the final answer. The speed with which Mary can swim is 2.5 kilometers per hour. In part C, we're asked to find the angle ACB. So we're not so much thinking about the marathon anymore. It's not really practical. We're just delving into trigonometry. We have a triangle and we know 3 sides and we're looking for an angle. In order to do that, we're going to use the cosine rule. If you go to your maths tables, the cosine rule is set up to allow you to find a side A. Now you can sub in straight away, but usually it's easier if you manipulate the formula in your maths tables to this. What I've done is isolated the cos A part of the equation. I want to work out this angle here. So in that case, this is what we're going to think of as our A. The side opposite it has to be my small a. So the small a, what I sub in for a squared, has to be 30. And then it doesn't matter which one is B or which one is C, it's 28 and 4, it doesn't really matter which is which. So all I did was I subbed in and I worked out a value for cos A. If I know cos A, I get cos inverse of the fraction and I end up with A is equal to 116.5 degrees. In part D, we're asked to work out the area of the triangle ACB. Relatively straightforward, we go to our maths tables. To get the area of a triangle, it's a half AB sine C, where A and B refer to two sides and C is the angle in between it. So we have to use 28 and 4 as our sides and the angle is 116.5. When you plug it into your calculator, your final answer is 50.1 kilometers squared. In part E, we're asked to find the shortest distance from the point C to the line AB. The shortest distance from a point to a line refers to the perpendicular distance. So if we draw a line from C perpendicular to AB, that's the distance we're looking for. We're looking for the distance from here to here, and let's just refer to this as x. Now there's a number of different ways of doing this, but the easiest way to do it is to consider what we did in part D. In part D, we worked out that the area of this triangle is 50.1 kilometers squared. And you remember from junior cert, the easiest way we have of getting the area of a triangle is half by the base by the perpendicular height. If I wanted to get the area of this triangle using that formula, it would be a half, and I could consider the base to be 30 and the perpendicular height to be x. So if I multiply a half by 30 by the distance that I'm looking for, that's the area of the triangle. We already know that the area of the triangle is 50.1 kilometers squared. So all I have to do now is solve this. I've got one equation and one unknown. I can find the value for x. I suppose the easiest thing to do first is multiply the half by 30, and on the left hand side I end up with 15x. 15x will be equal to 50.1. And to get x on its own, I simply divide both sides by 15. So x is 50.1 divided by 15. And if I plug all that into my calculator, I'm going to get my final value for x, the distance from C to AB. So when you plug it into your calculator, to one decimal place, your answer works out as 3.3 kilometers. So that's your final answer for part E here. In the final part of this question, we're told that vertically above A is the point T. The angle of elevation from B to T is 0.05 degrees. And we're simply asked to work out the distance AT. So we just have a right angle triangle, we know an angle and we know a side, so it's just junior cert trigonometry. Remember, we worked out in part A the distance from A to B is 30 kilometers. So in this case, we're looking for the opposite and we have the adjacent. If we're looking for the opposite and we have the adjacent, we're talking about the tan of the angle. I can say that the tan of the angle is the opposite, which is the distance AT, over the adjacent, which is 30. And then I multiply both sides by 30 and I plugged it into my calculator and I get 0.0261799 kilometers. But you'll notice that the question asked us to leave our answer in meters. So obviously there's 1,000 meters in a kilometer. So you multiply this by 1,000 and your answer to the nearest meter is simply 26 meters.